Hi guys, this is Dr. A. Vimla Bino, Assistant Professor from Mechatronics Engineering Department, SR Ministry of Science and Technology. I'm here to produce a video course on Process Control Engineering. This is the course we offer to our students who belong to BTech Mechatronics Engineering, 7th semester. This course consists of 5 modules. So before we enter into the 5 modules, let me explain what are we going to learn in each module. So to do that, I need to explain what is basically what is a control system, and then that has to be mapped with a general block diagram. Then uh, that block diagram is converted into each unit of this course. So let us do that now. For that, first I have to take this is the example. So this is the example of a liquid level tank. So this is the tank we can see in our general life. This is in apartments. For each house, they give one tank, or we can see in our own individual house also. So this is the tank. In this tank, my objective is I have to maintain this particular level. For example, 8 centimeter. So this is my target. But the current level may be anything. It could be 8 centimeter also, it could be 1 centimeter, it could be 10 centimeter. But whatever it is, it should always maintain 8 centimeter. If our requirement is at any level, it has to maintain this, then we know we don't need a control system. But since we have a target that it has to maintain at 8 centimeter, we need a control system. So how we are going to achieve this target? How we are going to reach this desired point? For that, we need to do certain things. One such thing is first I have to measure what is the current level of the tank. For that, I need a sensor or any measurement device. That measurement device will give you the current value. For example, my current value is 4 centimeter. So that has to be compared with the requirement. So my requirement is, my desired point is, set value is 8 centimeter. The other names given to this is set value or set point or desired value or reference value. So these are the names given to this. So this set value, and here is the current value. So both are compared. Since they are compared, I need to give the subtraction operation. So set value is my target. So plus, and then this is the current value, which is minus. So this difference is called as error. So this error is given to an algorithm. This algorithm will decide how much input or how much actuation should be given to the input so that the desired level is attained. So this is called as controller block. So here we have a set of algorithms. So this control algorithms uh, has taken this as the input, the error as the input, and the control algorithm will calculate the actuation, how much actuation that has to be given. So that actuation should be carried by a particular device that is called as a valve, control valve. So this actuation is given to the control valve. This control valve, based on the actuation, it will open the tap or it will close the tap, or according to the actuation, it will open the control valve, which means it will regulate the flow rate. Based on the flow rate, the level has to be maintained. So this is how the system works. So now let us map this control system with the general block diagram. This is the universal one. So this block diagram is very important. Based on this, the setup is made. So here our hero is the process. So this is the process. So this process could be industrial system like level control system, or temperature. If you want to maintain the temperature, then you have to take temperature system or flow system or pressure system, or suppose if it is not an industrial one, then we can take the climate. So if you want to measure a particular temperature in the climate, so that system is a climate system. And another example is robotics. In robotics, if you want to maintain if you want to make a robot to move from one point to another point, so the target point is a desired point. So in order to achieve that, we need a control system. So this process could be anything. So in order to achieve that, we need a measurement so that it says what is the current value. So the current value is given by the measurement. So this measurement or this device is always fixed at the process. From the process, it takes the current value, then that value will be compared. So these two comprises a computer or any processing device. So this device calculates the error between the set value and the current value. That error is given as input to the controller. The controller is a group of a bunch of algorithms. Based on the algorithm, it will calculate the output. So that output cannot be given directly to the process. So we need a device to, the device should work on that input. So this device is called as actuator. So there are many types of actuators, various actuators like basically pneumatic actuator, then hydraulic actuator, electric actuator, then the recent one is smart actuators. So these actuators will work on the control output on the process so that the process will reach the desired value. So this is how a general block diagram works. So in this, the first unit is about the process. So we are not going to discuss all the process in that, since it is this process control is for industry. So the basic industrial process or level process, then temperature process, pressure control process, flow control process. We are going to see these processes like level, temperature, and flow. So for this process, we are going to see what is the mathematical background behind these processes and how to find out the response if a particular input, standard inputs are given. So these important hints are discussed in the first unit. And the second unit is, because the measurement usually the students they study in their second year or third year. So we are not going to discuss this in this unit. So next point is controller. Controller is, I said, it is a device. So which has many control algorithms. So that algorithm we are going to discuss. First thing is we are going to learn about what is the basic characteristics of on-off controller. Then we are going to discuss standard conventional controllers like P, proportional and integral, derivative, then the combination of these controllers, PI, PD, and PID. So once we learn the controllers, then we have to give a criteria. I mean, every process has different criteria. So we have to fix the criteria. Based on the criteria, we have to select the controllers. So this is called a selection. So once we learn the characteristics of a controller, we have to go for the selection criteria and the selection of controllers. Once a controller is selected, then we have to learn the tuning, how to tune the control parameters so that your target is achieved. So that is also in the second unit. Then after that, just a small introduction about the system identification. So this is about second unit. Then the third module is the actuators. So what are the various actuators? So in this, we are going to learn electric actuators and pneumatic actuators. Then one such pneumatically actuated device is a control valve. So we are going to learn the mathematical modeling of the control valve and control valve characteristics. Then fourth unit is, apart from conventional controllers, we have some advanced control strategies like feed forward control, uh, cascade control, and internal model control. So those control schemes we are going to discuss in this fourth unit. And then fifth unit is, since we have discussed everything, then again we'll come back to the process. Generally, for mathematical purpose, we used to assume that process is a linear process, but actually all processes are not linear. Most of the processes are not linear. It is non-linear. So what makes the process non-linear? What are those non-linear elements? And we'll see one or two controllers in that unit. So this is how this process control video course is arranged. So before, let me enter into the first unit. First, let's see the what are the contents of the first unit. So this is the content. So first, in this session we are going to learn what is the need for process control, because we have already learned the process control introduction. So what is the need for process control? What are the terminologies we use in the process control, and what is the characteristics of the process? Then the upcoming sessions we'll see the other topic. So first, let me enter into the need. Before that, we have we can have many requirements, but those requirements are concluded as five important requirements. So that we'll see. After that, we'll move into the need for process control. But before that, the basic objective of the process control is to regulate. So the basic concept is, so we have to regulate the particular value at particular quantity. So regulate in the sense the quantity has to be maintained at desired value. Say for example, we have taken this level as say 8 centimeter, the current value is 4 centimeter. So we have to maintain this current value at the desired value 8 centimeters. So to do that, we need process control. So the objective of any process control system is to regulate a particular quantity to a desired value. So that's the basic objective. But overall objective is, from the industrial point of view, we have to convert the raw materials into desired products with the available sources of energy in the most economical way. Okay, so let's see what are the requirements of the process control system. Why do we need process control system? So first point is safety. For example, let us take one simple system. So here, this tank can withstand, for example, 1500 degrees Celsius. This tank can withstand 1500 degrees Celsius. So here, this is the inflow rate, which is it can have up to 2000 degrees Celsius. Okay, but at some point, if this uh, actually it has to maintain at the particular temperature, but in some cases, if it is beyond 1500 degrees Celsius, then we need to use the control system, process control, to regulate the temperature. Otherwise, this will be collapsed. The whole system will be collapsed because of this high operating temperature. So that is called as safety. In order to safeguard the system, we need process control. So the process control objective is to maintain the, because we already know that for whenever we make a device, whenever we make a component, we already know that what is the standard conditions, like it can work on it. So say for example, the flow rate or the temperature or the content of the liquid. So all these things we have to fix already. So in order to maintain that, we have to use a process control to ensure safety. For that purpose, we need a process control system. So this is the basic requirement. And then second requirement is products specification. So process means it converts the raw materials into desired product. So that product has to have some specifications. For example, if you take a chalk piece, so the chalk piece, while I write, it should not be brittle. So it has to maintain that particular components. What are the ingredients or how much percentage of ingredients have to be mixed. So those things have to be maintained properly. Then only we have a desired product. So that in order to maintain the quality, we have to maintain the ingredients level and the temperature condition, pressure condition. So in order to reach the product specification, we need a process control to do that. Then environmental regulations, we already know that this, for example, chemical process, so that exits the gas which affects the environment. But our state and federal laws, they have fixed the range for that gas. So we have to it's our duty to maintain a control system, to process control system, to maintain that particular level. So in order to maintain the level, we need to have a process control. So in that way, the environmental regulations are followed in this process control. Next one is operational constraints. So operational constraints in the sense, for example, if you take any tank, so the tank should not over dry. So we should always have a minimum level, like how we maintain a minimum balance in the bank. So that is a beautiful advice. So similarly, we have to maintain a particular level at the tank so that it should not over dry. So to maintain that level also we need process control. Then finally, our target is the economics. So for that purpose only we are doing this process control, or we are maintaining, or we are doing the products, or we are converting the raw materials into products. So that economics is based on how much raw materials we have, and how much potential, sorry, energy we have, how much human labor, how much investments we can do that. For all this, we need a process control to maintain based on the availability. We are going to fix the desired value. The process control has to follow the desired value. That's it. So these are the various requirements of the process control system. Then we'll move into the need. So what is the need for process control? Why do we need process control? So that is classified into three categories. So the first category is suppressing the influence of external disturbances. So here, in this example, this is the input, so which has the input temperature and the input flow rate, and then here this is the output flow rate or temperature of the tank. So here, what is the process is? So here, this is the inlet. That inlet has, for example, 400 degrees Celsius. This is the inlet temperature. But I need 1000 degrees Celsius. So how do I do that? For that, I'm using this steam flow rate, which is going to manipulate the temperature from 400 to 1000. So for that, the steam rate, maybe the temperature is 2000 degrees Celsius. So we need to regulate, we need to control the level of steam flow rate so that our target should be achieved. So this is the general system. So in order to achieve that, what we do is first we have to measure the current value. Here, my concentration on temperature. So that's why thermocouple is used. This is the temperature sensor. This is the sensor which is commonly used in the industry, thermocouple and RTD. So thermocouple will sense the temperature and gives the voltage as the gives output as a voltage. So that has to be compared with the set value, say for example 1000 degrees Celsius. Then the error is given to a controller. The controller is a set of algorithms, so that will give the actuation value. So that actuation is acted upon this control valve. Then based on the actuation, the control valve will be opened fully or partially or shut based on the actuation. Then accordingly, the steam is entered in and it will regulate the temperature. So this is a continuous process. So this is a basic control system. In that, if you have any external disturbances, for example, right now it is 400 degrees Celsius. Accordingly, the steam flow rate is regulated to make it to 1000 degrees Celsius. But suddenly, if there is any external disturbances, like if someone pours, so that carries like 400 degrees Celsius. So now it becomes 800 degrees Celsius. But usually the steam flow rate is in such a way that it will make 400 degrees Celsius to reach 1000. But now, due to external disturbances, it is 800. But even then, there is no issue. That 800 is measured by the thermocouple. Then the controller will take the action accordingly to reach 1000 degrees Celsius. So in spite of external disturbances, the process control works properly to achieve the target. So for this also, we need process control. So that's the need. So one such need is you have to suppress the external disturbances. Then second need is you have to ensure the stability. For any process, the stability is an important criteria that has to be maintained. Even when you go for the controllers, when you select the controllers, the main criteria is the stability. So stability in the sense, it should not be, for example, take this tank. So in this tank, say this is time, and then this is the level of the tank. So the level of the tank should not increase like this, because if it increases like this, the overflow happening, or suppose imagine that temperature is 1000 or 2000. So just imagine if it overflows, or it may cause the problem with the safety of the tank. So this is called as unstable. It keeps on moving. So we have to bring that temperature to settle at particular temperature. So that is called a stable. To bring that temperature to a stable condition, we need a process control. Okay. So in this example, here we don't have steam flow rate, but whenever you give the ingredients, so here for example, here we give these two ingredients A and B, that gives you C. So this C will exit or it will evolve some heat. So this is called as exothermic reaction. That heat should not affect the safety of this component. So we need some coolant. Then we are controlling the flow rate of the coolant so that the system will not be, or the safety will be maintained. For that purpose, we are going for the stability. So in the stability, in the sense, it should not keep on increasing. It should come to a stable point. For that, we need a process control. So here, this is the dynamics of this system. So this black line says how much heat is evolved at a particular temperature. So the actually the straight line is the linear one. This is the expected. So if this system follows this dynamics, then the system is under safety condition, which means stability is maintained. So see the curve. So this curve takes this profile and this profile. So if the curve is behind, means it is unstable. If the curve is above this level, means it is an unstable condition. So let's see this explanation of this concept with the help of the graph. So up to T1 there is no issue, but see from T1 to T2 the temperature is behind the standard profile. So this P1 and P2. So let's say here the graph is from T1 to T2. So we can say that, see here T1 and T2. So since it is behind the line, it is maintained. So this is a stable process. Okay. And then from P2 to P3, it takes from T2 to T3. So you see here. So since it is above the profile, the processes keeps on increasing. So this is not a advisable temperature. So I can say that but even though it settles, but if this temperature is not advised by the safety constraints of the tank, then this should be avoided. But this is okay. This temperature is okay. And then, but anyway, after that it settles at T3, and then here also it settles at T1. So this is a stable condition. But this, if T3 is beyond the safety constraint, this is unstable. This is also okay. So in order to maintain the stability of the system, we have to go for process control. This is the second need. Then third need is we have to optimize the process. Optimize the process in the sense with the availability only we need to go for it. For example, if it suppose if you have only limited availability, then you control the flow rate or the pressure, or if you want to maximize the profit with minimal investment means, then go for minimal pressure, minimal temperature. So finally, uh, in order to have the uh, maximum revenue, we need to go for process control, so that, because if you use the available resources properly, efficiently, automatically your profit will be maximized. So we need process control. So regarding the needs, we have seen three important things. One is to suppress suppress the external disturbances, we need process control. Second one is to ensure stability, we need process control. And then third one is to get the maximum investment, we need process control, which means with the available sources, we have to produce the maximum profit. So these are the three needs of the process control. Then we'll move into the terminologies. So what is measured variable or process variable? So here let's take the same example. So this is the level. So here I need to maintain the height of the tank or the level of the liquid. And then here is the inflow and then flow in, which is inflow rate. Here is the outflow rate. Okay. So here, what is my target? I need to maintain the level of the liquid. So that is your process variable. So here, my process variable or a measured variable is H. This is my process variable. So this we have to maintain. So once we decide the system, we have to list out the number of variables. From the variables, we have to pick because all those variables are not under control. Uh, or our main target is, suppose if we control this variable, automatically the system will come to stable condition or will reach the target. So we have to pick that variable. That variable is called as process variable. Okay, then manipulative variable is, so we'll just make a process control um, mechanism here. First, we need to have a measurement. So that measurement will give the current value. So that is compared with the set value. So this is plus, this is minus, this error. Error is given to a controller, which is a series of algorithms. So that is given to so here we have a control valve. So this is given to the control valve. So that's control based on the opening and closing of the control valve. The level is, I mean, the flow rate is increased or decreased to maintain the level. So this is the basic process control diagram. So the manipulator variable means, so which variable is going to bring the control variable to the set variable. So for that, here the manipulation is done through this. That is, we are going to manipulate this variable so that it will reach the target. So that is called as manipulated variable. For example, let us take a shower. Okay, so while we take a shower, the important the variable or the process variable is the temperature. So temperature of the water. So the temperature of the water should be comfortable with the person who is taking bath. So the process variable is the temperature of the water. Okay, that is a process variable. The manipulator variable is, suppose if your heat is too much, then we have to control the heat so that the temperature will be maintained, which suits the human body. So here the heater is the manipulative variable. So that heater or that heat input will make the variable, the temperature of the water, to be under safety condition, or it should follow the safety constraint. So that is the manipulative variable. So it is a variable which is going to manipulate the process variable so that it will reach the desired value. Okay, then set point, you all know that set value. Then control also, open control loop. So open control loop means if you are not particular about the desired value, then we don't need control system. Just open loop is enough. But if I want to maintain that particular desired value, a particular value, or it has to follow this safety constraint and then environmental regulations or economic, then of course we need closed loop control system. So these are the terminologies we use in this process control. Okay, so the next one is process characteristics. So these are the characteristics of the process, because once we know the characteristics of the process, then only we can implement process control on that. Then we can choose the controller, then control parameters. For all those, we need this. What do you mean by process characteristics? So here I'm going to present four important process characteristics. So one such characteristic is process equation. So here, take this example. So by seeing this example, I think one can easily understand. So this is the tank in which you have a inlet and you have an outlet. So the inlet is here, this is the Q, means this is the flow rate of the inlet liquid, the temperature of the inlet, and then here this is temperature of the atmosphere. So this is the temperature of the liquid which is inside the tank, and then QB is the flow rate. Okay, then QS is the steam flow rate and the steam temperature. So in order to maintain this temperature, this is dependent on here, or I can say this is a function of. So first, let's say, because in order to maintain the temperature, definitely QA has the impact, which is the inlet flow rate, and then input temperature, definitely. Suppose your your target is 500 degrees Celsius, and then your inlet temperature is 400, it is easily, uh, we can easily reach the target. So it is dependent on inlet temperature. Then it is dependent on atmospheric temperature as well. Okay, we know that the climate conditions definitely affect our day-to-day activity. So this is the atmosphere. So the liquid temperature is dependent on input flow rate, input temperature, and then atmospheric temperature. Of course, it is dependent on steam flow rate, and it is dependent on steam temperature. So we have to first create a relation between our target and then what are the variables that impact that particular variable. So that relation we should know. So that is called as process equation. Okay, so among these variables, my target is I have to maintain this. So except this process variable, other variables are considered as process load. For example, I said the initial temperature is 400 degrees Celsius, but suddenly if you increase this T naught from 400 to 800, definitely it will change the scenario. Similarly, this atmospheric temperature and then steam flow rate and steam temperature. So these are called as load variables. So general rule is other than the process variable or measured variable, the other variables are called as load changes or process load. If any, I mean, if that condition is changed, automatically it will affect the system. So the second characteristic is the process load. And then the third characteristic is the process lag, which means suppose, okay, so process lag, for example, you can take one simple system. So here I need to maintain the temperature of the tank. To maintain the temperature of the tank, I'm going to use the steam flow rate. So the steam flow rate is controlled by the actuation. So here is the steam flow rate. Okay, so we all know that suddenly if you switch on uh, the heat which we expect will not be in a minute. Okay, we all know that the best thing is cooler or the heater. Okay, because the process itself it has some laggingness, so that is called as process lag. Even though you apply control system, there is a delay in that. So before you get into the process, you need to know whether the process itself is a lagging process or a fast process. For example, level. So if flow rate is the fastest process, pressure also, and then level is okay. I mean, not faster or not slower. And then temperature is a slower process. So this process has lag, this process has little lag, but this process does not have much lag. So that has to be considered. So while you design a control system, we have to check whether the process itself has some lag or not. If it has some lag, then we have to take that point into consideration and you have to design the control system. Okay. Then self-regulation. Without, for example, this is the best example. So here is the level. So here is the inflow and then here is the outflow. Without any control system, the level is maintained. So that is called as self-regulation. Okay. Suppose if this outflow is constant, for example, here we fix a motor here. Okay. So this motor will give a constant flow rate. Suddenly, if someone pours water, external disturbance, what happens? The water overflows. So this point needs control system. For example, if you have this inflow and then this outflow means, so suppose if someone pours water, then accordingly this will be adjusted, then the water will be flowing outside. So I can say this is under self-regulation. This does not have the self-regulation. So before you decide a control system, you have to check whether the given process is under self-regulation or not. If the process is under self-regulation, then we know we don't need process control. We don't need any control mechanism for that because it is self-controlled. So this is for today's session. And in the next session, we'll see about what is liquid level and how to do a control mechanism for the liquid level system. And we'll see what is interacting tanks and what is non-interacting tanks and how the response is varied for interacting and non-interacting tanks. And if you implement a control system, how the target is achieved. So we'll see that point in the next session. Thank you.